Okay, so in this question we're given a curve with this equation, y equals 3x to the 4 minus 8x cubed plus 6x squared. And so the first part of the question says find the stationary points and their nature. Okay, so min, max, or point of inflection. Okay, stationary points are when dy dx equals 0, so let's figure out dy dx. 12x cubed, take 24x squared plus 12x. Okay, so let's bring 12 and x outside, so x squared, take 2x plus 1. We can do more with that, so that's x minus 1 times x minus 1. Okay, so when is dy dx equals 0? When x equals 0 or x equals 1. Okay, so there's the point. So x equals 0 is 0, comma. Let's put 0 back into this function, and it's 0, 0. Let's put 1 into the function, and you get 3 minus 8 is minus 5, plus 6 is plus 1, or 1, 1. Okay, so those are the answers. So now we need to work out the nature of them. So is it a local min, a max, or a point of inflection? Well, let's do the second derivative. So we know that y primed equals 12x cubed, take 24x squared plus 12x. Then the double prime, the second derivative is, what do we get here? We get 36x squared minus 48x plus 12. Okay, and let's plug in 0. So when we plug in 0, we get, okay, so we're trying to find out what kind of point this is. We get 12. Therefore, because it's positive, 0, 0 is a local min. And let's plug in 1, and we get 36 minus 48 is minus 12 plus 12 is 0. Okay, so 1, 1, which is this point here, is a inflection point. Okay, so that's it. So now we know that those are the two answers there. So, okay. Now we're also told, so the second part of the question says that the curve has two inflection points, one of which is located x equals 1, which we've got. So what's the second one? So the second one is when, so still we got the second derivative equals 0. So we got 36x squared, take 48x plus 12 equals 0. So we can bring a 12 outside. And we've got 3x squared, take 4x plus 1 equals 0. So we get 12 times, 3x take 1 times x take 1 equals 0. So x equals 1/3, or x equals 1. And so the second inflection point is this one. So we already know x equals 1 because we plugged it in. The second inflection point is 1/3, and let's plug that x equals 1/3 back into a function, and we're going to get, after all the simplification, we get 11 over 27. Okay, so that's the second inflection point. Okay, so now the third part of the question, let's see if we can squeeze it in here, is that we're also told that the function has an x-intercept at x equals 0, which we knew already because it's 0, 0, and no others. So based on that, let's draw a sketch of it. Okay, so let's see if we can draw a sketch of this. So we know it goes through 0, 0. We know it goes through 1, 1, because we're told that. We know it's got, and we also know that 1, 1 is a point of inflection, horizontal inflection, so it kind of goes around like that. And at 0, 0, we were told it's a local min, and there are no other x-intercepts, so the function kind of goes up like that. And we know at 1/3, 11 on 27, that's about a third again, so somewhere around there, there's another point of inflection, so it turns up like that, inflects, goes around like that, and then goes up that way. Okay, that's a sketch of the function.